So we've been talking about graphing linear inequalities and graphing systems of linear inequalities, and now we want to be able to use that skill to do a type of problem called linear programming. And actually our next 3 lessons will all be about linear programming, so we're going to kind of take it step by step and take it really slow so that you understand how all of this fits together. So let's refer back to problem number 5 in the 8.2 practice. It was a problem where we had a company that was manufacturing 2 types of skis, a trick ski and a slalom ski. And so we had the number of labor hours that it would take in the fabricating department and in the finishing department to help us set up our systems. And the graph we end up with is the graph that you see here. So the shaded area here represents all of the possible combinations of x and y, where the x is our number of trick skis and the y represented our number of slalom skis. So just based on the limitation in terms of labor hours in both of the departments, we know that we could pick any point now that's within this shaded region, and it would be a point that it would be a number of trick skis and slalom skis that could be manufactured and stay within the constraints of our labor hours. So maybe I could do 10 trick skis and 3 slalom skis, something right about there. Or maybe I could do 1 trick ski and make 18 slalom skis, right about there. Sorry, this would have been a 6 down here. Okay, but you get the idea. Any point inside of that shaded region would be a possible combination of x and y. Okay, well now let's add some additional information here. So the company can make a profit of $50 on each trick ski that it sells and a profit of $60 on each slalom ski that it sells. So without this information, anything in this section was a possibility. But to be able to narrow it down to what is the best possible combination of x and y, we have this additional bit of information, which is how much profit the company can make on the different skis. Okay, so if the company were to make 10 trick skis and 10 slalom skis per day, which is a point that we have here, it's right about there, 10 trick skis, 10 slalom skis, then they would end up making a profit of $1,100. Okay, so it's just a matter of taking the 50 times the x value of 10 for the trick skis plus the 60 times the y value of 10 for the slalom skis. That's where they're getting the $1,100 of profit. Okay, but now the question is there another production schedule that would also give you $1,100 of profit? So is there another combination of x and y that would also give you $1,100 worth of profit? And I want you to pause your video right now, and I want you to come up with another XY combination that would give you that $1,100 of profit. All right, so there are several possibilities here. One possibility might be the point 415. So at 415, that's about right there. That is another combination of x and y that would give you $1,100 of profit. And really, any XY combination is going to fall somewhere along this line. So the line made by those 2 points that does something like that. Any XY combination along that line would give you this $1,100 worth of profit. So you can see that there's a good part of that line that is within the shaded region. So anything along that line within the shaded region would be a combination of trick skis and slalom skis that could be manufactured to get this desired profit. Okay? Now, knowing where that line goes, is there a production schedule that will produce profit that is greater than the $1,100? Okay, so which side of this line would represent profit greater than $1,100? Well, that's going to be up here. And so anything within the shaded region still, but that is above that $1,100 line, would be a possibility for earning even more money. Okay, so it says, if yes, what is it? So if we just come up with a particular point, it might be a point like right there. Okay, which is the point 418. And if we put that point into the expression we had before, we could take the 50 times 4, which is the number of trick skis, plus 60 times 18, which is the number of slalom skis, and that's going to give us a total profit of $1,280. So obviously that's more than the $1,100 we were talking about before. And if I wanted to know other points that would give me this profit, then I could find another combination that would work for X and Y and then make the line through there. And what you'll find is that the line that would give you the 1280 would actually be parallel to this line, which gives you the 1100. So if you imagine that this line is just being moved to different values for our profit, then you can kind of start to visualize where the maximum profit would be. And so that's my next question here is, where do you think the maximum daily profit would happen? What production schedule, how many trick skis and how many slalom skis would you have to manufacture in order to get the maximum daily profit? The video is going to pause here in just a moment. It's going to ask you to answer that question on the Zaption. I'm not coming back after that question to answer it for you. I want you to think about it. Put your answer in the appropriate place, and then we'll talk about it as we begin our next class when we meet again next time. So this is it for today. Make sure you answer the question before you exit out of Zaption, and then we'll see you next class.